Now, last lecture, what we have discussed, if we have a cubic expression, E of x, P of x is equal to, say, ax cubed plus bx square plus cx plus d. If it has integer root, suppose it has. If it does not have integer root, then we are in trouble. But suppose it has integer root, and that integer is between 1 to 3 and -1, -2, -3, then we are supposed to check for every integer. Is this equal to 0? Yes, x minus 1 is a factor. No, try something else. E of opposite of x. Is this equal to 0? Yes, x plus 1 is a factor. No, try something else. P2, is this equal to 0? Yes, x minus 2 is a factor. No, p minus 2. Yes, x plus 2 is a factor. No, p minus 3. Yes, then yes, x plus 3 is a factor. P, no, and p plus 3. Yes, x minus 3 is a factor. And maybe you are tired by this time, and then you will say that it is difficult to factorize this. If you don't get 0 for the 6 integers. Now, if I am suppose setting up a question paper where there is an integer root but that is not amongst them, maybe I will try for P4, P of -4. But normally, nobody will expect you to try these numbers. And if we cannot find first root, then it's difficult to factorize. That is what is, I mean, people before this computer development, people have got methods of solving cubic. The way there is a method for solving quadratic equation, people have developed method for solving cubic expressions, but the method is very involved. But there is a method by which you can solve cubic. But then fourth degree is difficult, fifth degree is difficult, and therefore, unless and until you use calculus these days to solve these equations, it is going to be a difficult task. And hence, your first root, you should have tricks and techniques to find out your first root very quickly. If you get one of them using these methods, trial and error, then you can pull out that factor from the cubic, then the rest is quadratic, and you can factorize quadratic further if it is factorizing, getting factorized. Otherwise, it is going to be difficult. So, this is as far as integers are concerned. These are all the testing that we have done is for integers. Now, if these coefficients A, B, C, D are integers, they belong to Z, integers. And if suppose there are no integral roots for this cubic, but there are rational roots, P of half might be 0, P of 3 upon 7 might be 0. and then x minus 3 upon 7 if you pull out, you get second one as a quadratic and you can solve that. So integer trial and error if you fail to get an integer, but if there is a rational root, is there any method by which we can find it out? That is the question. Suppose I design a question deliberately. Suppose I can get a cubic design like this. P of x is equal to 2x minus 1, 3x plus 2, and 5x minus 2. Whatever cubic I will develop out of this will not have integer root because it gets factorized like this. Then P of half is going to be equal to 0 because if you put x is equal to half here, this factor is going to become 0. P of minus 2 by 3 is going to be equal to 0 because this bracket is going to be 0. And P of 2 by 5 is going to be 0 because this bracket will make it 0. However, if you really try and work hard to solve, will this have integer coefficients? Yes. Shall we multiply and find out what cubic is this? 45 so 90x cube. Okay, so let me do it quickly in this way. 6x square 4 minus 3 is plus x minus 2 multiplied by 5x minus 2. 6 30x cube. Then how many x squares? 6 into 2 minus 12 plus 5, that many x squares. So minus 7x square. How many x? Minus 10 minus 2, that many x, minus 12x plus 4. Now, no matter how good you are in algebra, if I give you this cubic and ask you to factorize, there is no way by which you can arrive at these factors. It is easy to multiply these three factors and get this. So maybe I can say this is easy, but this is extremely difficult. Understand this? And therefore, you need to have a trick or a technique by which you should be able to confidently say whether the given cubic has got rational roots or not. Rational roots means roots in the form p upon q, whether they are there or not. And therefore, there is a theorem by which we can be assured if at all there are rational roots, then you try these many rational numbers. And if you fail to get these many rational numbers equal to 0, then there are no rational roots. That kind of confident statement which we will be able to make by learning a theorem whose name is possible rational root theorem, PRRT. Okay, so that is the theorem that we are going to do now. Do you understand what I am trying to teach you right now? If there is a cubic expression and if it has not only cubic, any general expression, any polynomial, and it has got a rational root, then we will be able to predict some rational numbers, which if we try and if we get 0, then yes, and if we don't get 0, then it has not rational root. It does not have rational root. That is what is the level of confidence which we should be able to get. So let me write down.
But isn't half also a rational number?
Yes, of course, half is a rational number. What do you think half is otherwise? What is half? Is half an integer?
No, sir, if half is a rational number and we find out that an expression has rational roots, then
Yes.
how is it going to help us?
Yeah, we come to know that this particular expression p of x has half as a root. Let us check. I mean, if my calculations are correct, we should be able to get half as a root. P of half is equal to 30 times half raised to 3 minus 7 times half raised to 2 minus 12 times half plus 4. Okay, so 30 upon 8 minus 7 upon 4 minus 6 plus 4. Is that correct? Is this equal to 15 भागिले 4?
Sir, minus 7 upon 4. You wrote minus 4 upon 4.
Ah, this is minus 7 upon 4. So this is 15 by 4. So 15 minus 7 upon 4 minus 2. Is that equal to 0? Yes. So x minus half is a factor of this. So we can always pull another factor, which is 30 x square. If we have 30x square into x is 30x cube, 30x square into minus half is minus 15x square. I have got minus 15 with me. I want minus 7. So plus 8x. Now I have created minus 4x. I want minus 6, minus 12. I have created minus 4. I want minus 12. So I want additional 8 minus 8x. बरोबर चाललंय? Minus 8x minus 4x minus 2x. Correct. And then minus 8 into minus half is 4. So I got the second factor. And after I get the second factor, I should be able to factorize this using quadratic. Now you can see that 2 will come out and it will go here and it will make 2x minus 1. That is what this factor is. So if you come to know that there is a rational factor, method or the other, it is going to be a very, very good technique with you, which others will not have. And therefore, writing and solving possible rational root theorem is extremely important. Possible rational root theorem. PRRT. Let a of x is equal to an x raised to n plus minus 1 x raised to n minus 1 belong to rational x. R of x normally we लिखो a of x belongs to R of x लिखो. Now I am writing a of x belongs to integers of x. So all the coefficients a0, a1, n are integers n greater than equal to 1. Okay. Let h comma k belong to z be such that GCD of h comma k is equal to 1. If h upon k is a root of a of x is equal to 0, then now I am not completing the statement of this theorem. We will figure out what should be the condition that we should get so that h by k is a root of a of x is equal to 0. H by k is a root of a of x is equal to 0. That is what is the interesting part. Okay. So I will leave some space for, or shall I give you theorem and ask you to prove, or shall I derive the theorem and then complete the statement of the theorem? Then, okay, I will give you in between. You have to find the relationship. This is the hint. There is a definite, if h upon k is a root of given polynomial, then there is a definite relationship between h and a0, which is a numerator and a constant, and denominator and a leading coefficient. Okay, there is a relationship. Now you spend some time and try to derive this theorem, statement of this theorem, take couple of examples, check whether your conjecture works or not. Think about it. If you come up your own with the statement of possible rational root theorem with proof, nothing like it. Otherwise, after some time we will discuss. Okay, the statement of the theorem is then h must be divisor of a0 and k must be a divisor of an. Okay, that is what is the relationship between h and a0 and k and an. Prove this now. Write down complete correct proof. So I wait for 5 more minutes. For those who could not find the relationship, at least they should try and find what is the proof of this. H must be divisor of a0 and k must be divisor of an. Now an and a0 both are fixed because you have been given the polynomial. So you know these numbers numerically and you know their divisors. So total number of h comma k that you need to try are limited now. They are finitely many. You need not try infinitely many numbers. It is okay if you try finitely many numbers. So that is the advantage of this theorem. So I give you 5 more minutes to write down the proof. It is easy. Try your level best. Okay, let us write down. Let h comma k be a root of a of x is equal to 0 implies an h upon k raised to n plus an minus 1 h upon k raised to n minus 1 plus n minus 2 h upon k raised to n minus 2 plus a1 this is going to be equal to 0 because if it is a root it should make that polynomial identically 0, right? Therefore this is going to be 0. Now a1 a2 an are integers. Note and h comma k also belong to z. Therefore, the highest denominator is k raised to n. So if we multiply throughout by k raised to n, we get denominator free expression an h raised to n plus an minus 1 h raised to n minus 1 k plus an minus 2 h raised to n minus 2 k square plus dot 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 plus a2 h raised to 2 k raised to n minus 2 plus a1 h k raised to n minus 1 plus a0 k raised to n equal to 0 into k raised to n is equal to 0. We get this expression, and therefore now if you see all the terms in between except except this term and this term have two terms h as well as k, h as well as k, h as well as k. The GCD of h and k is 1, so they are distinct prime numbers or distinct numbers, not necessarily prime, distinct numbers. Okay, so if I take suppose a0 k raised to n to RHS, what will I get here is all terms with h as a common factor. H inside bracket an h raised to n minus 1 plus an minus 1 h raised to n minus 2 k plus dot 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 plus a2 h k raised to n minus 2 plus a1 k raised to n minus 1, because I have taken out h common and I can transpose this to the RHS minus a0 k raised to n. And now if I take h to the denominator, because h is not equal to 0, I can take it, always take it in the denominator here. And then if I observe this expression, LHS is an integer because n is integer, h is integer. N minus 1 is integer, h and k both are integers. Everybody in LHS is integer. Implies RHS must be integer. Okay, so either h must get absorbed in k or h must get absorbed in a0. But is there any way by which h can get absorbed in k? No, because their GCD is 1. This implies h divides a0. Do you understand this? It is extremely important and easy that way. Similarly, you can prove k divides n. This is possible rational root theorem. Now, if you have integer root, of course it will follow PRRT because integer is a rational number divided by 1. If we consider, then it is a rational number. But if it has got integer root and if it is not amongst 1, 2, 3, minus 1, minus 2, minus 3, then also you will come to know using this theorem. That is the advantage. Plus, if it has got rational root, then by this method you will be able to identify how many rational numbers I need to test for the root purpose. Now, this is what is theory. What is the application? Now, before that, let me tell you a story. Suppose I give you. Now let me give you a problem. Problem is P of x factorize P of x is equal to 3x cube minus 10x square minus 18x plus 7. Okay. Now, this kind of polynomial was given in IIT Mumbai for the first year BTech students. I am not aware whether you are aware or not, but in IIT Mumbai, if you get admission for BTech course, you are amongst the topmost rankers in the country. Okay, so if you get into IIT Mumbai, it is great, good job, very good rank you must have for getting into IIT Mumbai. So in IIT Mumbai, once upon a time, about 8, 9, 10 years before, a mathematics professor gave a problem like this to students of first year engineering. Amongst all 70, 80 students sitting in the class who are 12th standard IIT rankers, best rankers in that class, except one student, no other student could factorize the polynomial. Then the professor was surprised because he was expecting not a single student will factorize it, and he got one student who factorized the polynomial. Then he went to him and found out how he has done. Or he asked him, how have you done? What are the factors? And he said the correct factors. Then he asked him, how have you done? Then he said, sir, I know possible rational root theorem, PRRT. Okay. And that is not there in the syllabus of IIT. Therefore, no other student in that class was aware of this theorem. And because I will not quote the name of the student because this is getting recorded, because the ex student was aware of PRRT, he applied it, he found out the first root, and then reduced it to quadratic and found out the second root and third root, and hence he could factorize. Then out of the interest, the professor asked him, which institute do you belong to? And of course, because I know this story, student was of Prakash Academy, and he said, sir, we learned this theorem when we were very young. When I was in 9th standard, I learned this theorem. And the theorem was not known to 12th standard based IIT rankers in that class. Okay, so this is what is the importance of the course that we are learning. Now, moreover, that XYZ student was so good that he could remember the theorem which was learned in 9th standard 3 years before, and he could use that theorem to solve problem given in IIT classroom. So that is the greatness of that student, that he remembered it and used it. Okay, so I hope you have understood the meaning of this example. Moral of the story is known to you. So that is what is the background of all the theorems that we are doing. You might find that, अरे क्या चल रहा है, काय करतोय काय मी तर आता खरं काय करायला पाहिजे, खेळायला पाहिजे, बागडायला पाहिजे, मी नववीत आहे. अरे पण तसं नाहीये. You are not amongst those. You are little different than others, and if you make best use of this time that is available to you, you are going to be far ahead of others. Okay, so after learning that theory and example, you give me the factors of the polynomial which I have given you. Our PRRT says numerator of the rational number h divides a0. Okay, so in our problem a0 is 7. So h can be equal to 1, -1, 7 or -7. K divides an. In our problem an is 3. Therefore, k can be 1, -1, 3, -3. So h upon k, if we try to find out all values of h upon k, 1 upon 1, that is 1, 1 upon -1, that is -1, 1 upon 3, 1 upon -3. So now if I take 1 and permute all these, then I need not permute -1 because it is one and the same. -1 upon 1 is -1, -1 upon -1 is 1, -1 upon 3 is 1, -1 by 3, -1 upon, so it is done. 7 upon 1, so 7, 7 upon -1, so -7, 7 upon 3, 7 upon -7 upon 3. Again, I need not have to permute. So practically, if you try 8 numbers, these 8 numbers, and if the given expression has got rational root, then one of them will definitely work. And if none of them work, then P of x will not have rational roots. That is the application of this theorem. Now, as far as 1 and -1 is concerned, you can easily cross-check that it is not becoming 0. So, what you need to do is you start doing this. So, try for 1 by 3, try for -1 by 3 everywhere. And then you will realize that it has got first factor. If you put P of 1 by 3, let us find out. That is what is our first number, which is equal to 3 upon 3 cube minus 10 upon 3 square minus 18 upon 3 plus 7. 3 upon 3 cube is 1 upon 9 minus 10 upon 9 minus 6 plus 7, which is equal to minus 9 upon 9 plus 1, which makes it 0. So this is a factor. So if you consider this as a factor, either you can consider it as x minus 1/3 or you consider it as 3x minus 1. 3x minus 1, if you put x is equal to 1 upon 3, this factor becomes 0. Therefore 3x minus 1. If I want 3x cube, I need to have x square. The moment I wrote x square, I created minus x square. I want 10x square. So I must write 3x here. So minus 9 minus 1 minus 10. The moment I write minus 3x here, it is plus 3x. And I want minus 18x. So I must write minus 21 I should get. But 21 upon 3 is 7. That is what is my second quadratic, and the last parameter also matches. Minus 7 minus 1 is 7. So this is my quadratic. So I can factorize this quadratic saying that x minus 3 plus root 9 plus 28, 37 upon 2. That is second factor. And x plus 3 minus, no, x minus 3 minus root 37 upon 2 is the third factor. That is how it gets factorized. Now, because we have done this theorem today, you could factorize this. Otherwise, it was impossible for you. So if this was not working, then you should have tried this, then this, then this, then this. And if the polynomial has a rational root, then it will, this particular theorem will supply you that root. Otherwise it does not have rational. Okay, now quickly, each one of you should get a complete factorization of P of x. Two x cube plus 7x square plus 3x minus 5. चला करा बघूया पटकन. Getting started. The factors for this, again you can make a table like this, earlier one, and h will be divisor of 5 and k will be divisor of 2. Again 2 and 5 are prime numbers, so they themselves and their opposites, so total 8 numbers you have to try. And if you try p of minus 5 by 2 or 5 by 2, that makes it 0, correct? Minus 5 by 2 will make it 0. So 2x plus 5 is a factor, and then second factor will be x square plus x minus 1, which again will get factorized into two factors. Okay. So now you are aware how to deal with the PRRT and get the rational roots in place. Okay. Solve. Solve simultaneously. X plus y plus z equal to 7. X square plus y square plus z square is equal to 17. And x fourth plus y fourth plus z fourth is equal to 130. Get me all possible ordered pairs, ordered triples, which will satisfy these three simultaneous equations. Okay, so now basically if we come to know what is sigma 1, which is equal to 7 in this case, if we come to know what is sigma 2, and if we come to know what is sigma 3, we can form a cubic and solve it to get x values of x, y, z, right? So right now directly sigma 2 is not given, but s2 is given. 17 is equal to s2 is equal to sigma 1 square minus 2 sigma 2, right? And sigma 1 is available, therefore 17 is equal to 49 minus 2 sigma 2 makes it 2 sigma 2 is equal to 232. So sigma 2 is equal to 16. Is that right? Yes. So now you have sigma 1 with you. Now you have sigma 2 with you. You need to search for sigma 3. And we have third expression which is left with us is actually S4.
Sigma 1 is minus 7. Or no, sorry.
Huh?
Sir, nothing.
7, na? S4 we need in terms of whatever numbers that we have. S4 is x raised to 4 plus y raised to 4 plus z raised to 4. So if we imagine this as S2, then S2 of x square, y square and z square then what we can write is x square plus y square plus z square bracket square, that will produce these three terms, but it will produce something extra also. What will be the extra terms that it will produce? This is sigma 1 square minus 2 sigma 2. So sigma 2 will be x square y square plus y square z square plus z square x square. See if you understand this step. This is equal to S4. It is in terms of, this is S2. S2 square minus 2 x square y square plus y square z square plus z square x square. Now we have to create this term. So x square y square, now you can look at it as S2 of x square y square plus y square z square plus z square x square is equal to xy plus yz plus zx bracket square, which is equal to, minus 2 xy square z plus x square yz plus xyz square, right? So we got this term in terms of sigma 2 at least, which is equal to sigma 2 square minus 2. I think we can factorize this. X comes out common, y comes out common, x, y, z into x plus y plus z. Oh, I think we are done saying that this is sigma 2 square minus 2 sigma 3 sigma 1. That is what this term is. So S4 is equal to 113 is equal to S2, which is 17 square minus 2 sigma 2 square minus 2 sigma 1 sigma 3, right, which is equal to, which implies 2 into sigma 2 is how much? Sigma 2 is 16. 2 into 16 square minus 2, how much? 7 into 7 into sigma 3. That is what this quantity I have taken it to. LHS is equal to 17 square minus 130. Let's solve this and get sigma 3. Then form cubic. T cube minus 70 square plus 17t bar. I think it will be 12. Kara, complete kara. Find sigma 3 first. Then solve this cubic and get values of 3 distinct values of t. Assign them to x, y, z. Create all permutations and report your answer. Okay, correction here. I had written 17. It should have been 16t. Next problem. All of you, those who have not completed this, find out the solution set properly. Those who have completed, I am giving you another problem. Solve x plus y plus z is equal to minus xyz, xy plus yz plus zx is equal to minus 1 and the third relationship is 1 plus x square, 1 plus y square, 1 plus z square is equal to 20. So, okay, this problem I will solve in the next lecture if required, but the solution set I can write and give it to you. Solution set one minus one, two. 1, 2, minus minus 1, 1, 2. Then it gives minus 1, 1 minus 1, 2, 1, 2 minus 1, minus 1, 1, 2, minus 1, 2, 1, 2, 1, minus 1, 2, minus 1, 1, then 1 minus 1 minus 2, 1 minus 2 minus 1, minus 1, 1, 2, minus 1, minus 2, 1, minus 2, 1, minus 1, minus 2, minus 1, 1. दोन तीन चार पाच सहा सात आठ नऊ दहा 12 ordered pairs, ordered triplets is a solution set of this problem. Now, how do you go about it to get these numbers? See, these three expressions which are given to you are symmetric. Okay, but because sigma 1 is equal to minus sigma 3, this plus minus business is making the number of solutions more comparatively. Arriving at 1, 2, minus 1 and 1, minus 1 and 2, minus 2. Check how you go about it, which cubic equation eventually you have to solve. Find out, try to solve it, and let me know whether you get these answers or not. Next lecture beginning, remind me of solving this problem first, followed by some new problems. That is where we are going to stop. Okay, solution set for the previous problem was S is equal to 2 to 3, 2, 3, 2, 3 to 2. 3 ways. That was the solution set for previous problem. This is the solution set for new problem. Okay, that is where we stop for the day.